Okay, ठीक है. Hello. So now I'm going to give an explanation to the experiment with the title uh, load test on DC compound generator. Okay. Now before explaining anything about this experiment, I would like to tell something about a compound motor. The meaning of compound is a combination of two or more things. So that is the basic meaning of compound. So here we are talking about compound generator, means it is made up of two different kind of generator. Okay. Now the basic definition of compound is because I have a series field winding and a shunt field winding. Because of these two field windings, I am saying that this generator is a compound generator. In case of shunt generator, only this is present. In case of series generator, only this is present. But in case of compound, both series and shunt is present. That is why it is a combination of series and shunt effect. So we call it a compound generator. First thing, okay. Again, this compound generator has many types of classification on different bases. Particularly, they are classified on the basis on three bases. First one, how these two are connected. Okay. Depending upon the way these are connected, there are two types of compound machines or two types of compound generator. One is long shunt, another is short shunt. In this experiment, we are going to use long shunt. Okay, what I told you that on the basis the way the series field winding and short field winding are connected, there are two types of compound generator. One is long shunt and short shunt. In this experiment, we are going to use long shunt. Okay, next, how the action here and the action, something is going on here and something is going on here, how they are interacting with each other. On the basis of the nature of interaction between here and here, we have two different types of compound generator. One is cumulative and another is differential. In this experiment, we are considering cumulative. Okay, next classification on the basis of like this one, how the external characteristics looks like, and on the basis of external characteristics, I have three types of compound generator. One is over compound, flat compound, and last one is under compound. In this experiment, we are using flat compound. So the actual name of this experiment should be load test on long shunt cumulative flat compound DC generator. Okay, DC. This is what we are going to do. Okay, these things we are going to study in more detail in theory class. But right now I am telling you that in this lab we are going to consider a compound motor which is long shunt, cumulative, and flat type. Okay, next. So what is the objective of this experiment? The name of the experiment is load test on compound generator. So the objective of this experiment is to determine the external characteristics of this compound generator, means to get a graph like this one. Okay, now what is the meaning of external characteristics? The graph between Vt and IL is going to give you external characteristics. The graph between Eg and Ia is internal characteristics. So we are going to obtain these two characteristics of this compound generator. That is the objective of this experiment. Okay, now how? So what I am going to do is that first I told you what is the objective. My objective is to find out internal and external characteristics. Then I will tell you what is this circuit, what are the elements in this circuit, what are the measuring equipments. Then I will tell you how the circuit is operating, and after the operation how to fill up this tabulation, and from this table how to get this graph. Once from the table we draw a graph, my job is over, my experiment is over. Okay. So now let us see about this circuit diagram. Now in this, the name of the experiment is load test on compound generator. So DC compound generator. So this is my generator. Okay, this is my generator. Now this generator Now I know that a generator needs a mechanical input and it gives electrical output, and this mechanical input to this generator is given by this motor. That is why this motor is there. The purpose of this motor is to supply mechanical energy to the generator so that this generator can convert this mechanical energy into electrical energy. Okay, now here in this generator, this is the armature A. We have a series field winding Y. We have a shunt field winding Z. We have a rheostat here. We have a ammeter here. Then we have a voltmeter here. We have a ammeter here. This is my load. This is my load switch. This, when I switch on this load, then and only then this load gets connected, and this load is a variable load. Okay. Now 1 minute, I'm missing something. Okay. This one is having 370 ohm by 1.7 ampere. Okay, same thing. Now, okay, so next what? Okay, so this ammeter is measuring the current flowing here, or since this is the field winding, so this ammeter is measuring field current. This field current is nothing but IF. This is your IF. Okay, now this voltmeter, it is measuring the voltage that is generated across this generator. The voltage across the load or terminal. So this is not VT. This voltage is measuring VT. So this voltmeter reading is this VT. Okay. Next, this one. This one is the ammeter. This ammeter is measuring the current that is flowing through this load, and this load. That is why this ammeter is measuring load current. This IL. Okay. So from this experiment, we are going to get IL, IF, and VT. These two things we have to calculate. We will see later. Okay. So let me say that, okay, so what I need, let me say that this generator, okay. Now come to motor. This motor, okay, we have A armature, we have a rheostat, we have a field winding of the motor, Z. I have a 3-point starter, I have a fuse to protect the circuit from overcurrent, I have DPST switch, double pole, single throw, and I have a supply to 20 volt DC. Okay, so this is the basic circuit element. Now here this is apparatus required. I have mentioned here ammeter, two different ammeter. One is 0 to 20 ampere, another is 0 to 2 ampere. Okay, this is used for load current measuring. This is used for field current measuring. This voltmeter 0 to 300 volt. It is used for measuring load voltage or terminal voltage. All are MC type or moving coil type. Then I have a rheostat. I have two rheostat, 370 ohm by 1.7 ohm. The meaning of the ampere. The meaning of that is that this rheostat is a variable resistance whose values can be varied from 0 to 370 ohm, and we should take precaution that the current through this one should not exceed 1.7 ampere. If it exceeds 1.7 ampere, then this thing will get overheated and the complete thing will get damaged. So it is our responsibility that to take precaution that current here should not be more than 1.7 ampere. That is very important. Then tachometer, the purpose of tachometer is to measure the speed of the motor. Okay, and with the range, the rating is 0 to 300 rpm. It is digital type. Okay, next nameplate details. Nameplate details, I am using two machines. One is a motor, one is generator, and they have these are the ratings that is written on the plate of the machine. The voltage, current, output, and speed. So for motor, voltage is 220, current is 20 ampere, output is 5 HP, and its speed is 1500 rpm. For generator, its voltage. When I am talking this voltage terminal voltage. Okay, see this voltage is this terminal voltage. Okay, now this current here, this current is this current, load current. It is not IF. Remember something. The current that is given on the nameplate detail is the load current. It is not this current. It is not this current. Okay, so this one is load current. Then output is 3.5 kilowatt. And the speed is 1500 rpm. Okay, so this is the basic structure, a basic circuit components. Now I am going to tell you what to do, how to conduct the experiment, what is the step. Okay, now please see here. You start. So you start two resistors. Okay, here see the arrow mark. It is on the top. It is at the bottom. Okay, so that is what we have to understand now. If you understand those two things, then everything will become clear. Okay, so first, let me say I want now what I want. I want that this generator should supply to the load. Let me say that this generator is being rotated, or the speed of this generator is for 1500 rpm because of the operation of this one. Let me say that How we are getting this speed we will see later. Let me say that this is rotating at 1500 rpm. This is mechanically coupled to this one, mechanically coupled. That is why if it is rotating at 1500 rpm, then it will also rotate at 1500 rpm. Okay. So now let me say that it is rotating at 1500 rpm. So at the starting, what I will do that I will keep this switch open. Okay, so if it is open means there is no load connected, no load means no current passing. Okay, I'll keep the switch open. Next, how much voltage I am going to get? Now, question is what is the use of this one? What is the use of this rheostat? Generally, what happens is that the rating of this generator is 220 volt. The meaning of when I get 220 volt, when I give rated current, rated field current, and the rated speed. When I give rated speed and rated field current, then and only then I am going to get a voltage of 220 volt. Now what I have done is that right now only the speed is rated, this current is not rated. So what I want, what is my general normal expectation is that my voltage of the generator, it should keep on slowly increase to its rated value. It should not suddenly go to 220. The value is 220 volt now. It should not go jump directly to 220 volt. It should slowly go to 220, and for that purpose we are using this rheostat. What it is doing is that since now see this pointer is here, this means the current here is flowing through entire resistance, means it is facing maximum resistance. If it is facing maximum resistance, the current is minimum. If the current is minimum, flux is minimum. If flux is minimum, then EG, the EMF developed is minimum. Okay, so this means that if I keep on decreasing this resistance, I'll keep on increasing current. If I keep on increasing current, I'll keep on increasing flux. If I keep on increasing flux and the speed is constant, the voltage generator will keep on increasing. So this is here is to control the way we are increasing the voltage or the increasing the EMF generated across the generator or armature. That is the purpose. Again, the purpose of this one is to control or to vary the EMF that is being generated here slowly to its rated value. Okay, next, now come to here, this part. Okay, now what I told you, so okay, sorry, so we got here, now let me say that I moved this one to up to this position, and after that one I am getting the rated voltage of 220 volt. Okay, now my switch was open, now I'll switch on one. Okay, now I'll switch on, then I'll keep on changing the loads. As I keep changing the load, since I change the load, my load current is going to change, so this thing will keep on changing. As I will note down all the value, and this thing will change, all these thing values are, this IL will change, this IF is going to change, this VT is going to change. We are going to see in this experiment. Well, when I am going to conduct the experiment, we are going to see that as I am changing the load, this will change, and this will change. Okay, we are going to observe everything and we will note down. Okay, next thing. So this is what we got from this one. Now the question is that how to get this 1500 rpm. To get this 1500 rpm, we are making this arrangement. Now I have a motor. I know that a motor takes electrical energy and gives mechanical output. Okay, and this electrical input is here 220 volt DC, and mechanical output is speed that is being given to the generator. Okay, now here what we have done is that I have a fuse here. I have already told you to protect the circuit. Okay, now here in this case the rheostat is at the minimum position. Why minimum position? Because if it is in minimum position, the current is maximum. If the current is maximum, flux is maximum. If flux is maximum, then speed is minimum. Because again, my expectation or my ideal way to operate a motor is that its speed should start from 0 to some particular value. It should not jump to 1500. Suppose the rating of this one is 1500 rpm. This means that its at the final value should be 1500 rpm, but it should not jump suddenly. It cannot jump actually. It has to increase slowly. And to do that one, we are having this one. Okay, so this is how we are going to control the motor, and from this motor we can control the generator. Once this experiment is over, I get IL, I get IF, I get VT. I get these three things. I'll get this one, I'll get this one, and I'll get this one. I'll not get this one, I'll not get this one. Now you can draw these characteristics VT and IL from directly these two, because these two things you are getting from experiment directly. You can draw external characteristics directly, but you cannot draw this thing. To draw these things, you have to find out this one and you have to find out this one. And to find out this one, the formula you have to use is this one, IA is equal to IL plus IF. And to find out EG, you have to use this formula, VT plus IA into RA plus RAC. What is RA? With the armature resistance. What is RAC? With the series field resistance. Okay. And these things are, it will be told, if you want, we can do an experiment to find out RA and RAC. Otherwise, we have already done the experiment and we know the value, we are going to give you directly. It depends upon the time available. Okay. Next, once we have this data, then you can draw it. Once you draw this one, your job is over. Since this experiment is related to long shunt cumulative flat compound, sorry, flat, not flat, sorry, it should be under. Sorry, it should be under compound. Okay, no problem. Under compound, we are going to get a graph in this one. We'll get a graph like this one, something like shunt. Okay, so next I'll go to the panel, and at the panel I'll do this experiment, and whatever I have told you, we are going to see practically what happens there. Okay, thank you.